This mechanism uses two spur gears to drive a piston. The housing for the spur gears experiences rotary translational motion, while the piston itself produces reciprocating motion. You'll notice that the spur gears have identical teeth, and they both rely on an eccentric shaft in order to provide the motion conversion. This particular design does not work well when you try to apply force to the piston in order to try and turn the gears. There are dead points, and there's not enough inertia in the mechanism itself to continue that rotational energy. You'll notice that when we turn it by hand, it doesn't spin too freely. There's some play in here and some tolerances that are not exactly great, but it does function. When we put it into a drill, you'll notice that it works a whole lot better. You're noticing a whole lot of shaking, a whole lot of vibrations, and that's just normal, just part of the design. Here's a slow motion view. You can see that it shakes around quite a bit, but it also produces a very powerful motion into that piston. So what I did is put this little piece of plastic in here and then just try to eject it out. And there it goes. It's pretty fun. So is this something that you can print? Is this something that you could use from a 3D printed standpoint? I'd say, yeah, you could. The applications for this are up to your imagination. Better design and better tolerances would yield much better results. I've been inspired to learn more about mechanical design by retired mechanical engineer and YouTuber Thang010146. His YouTube channel has over 3,000 mechanical animations that he created himself, and he's constantly creating new ones almost daily. I've been a fan for a while now, and I would like to challenge myself to recreate some of his designs and 3D print them to see how well they function out of a printer. He's a genius. You gotta check him out if you're interested.